Hello everybody, this is Chris Love, the owner of Love to Dev, and I just wanted to go over the service worker in the Philly.net Code Camp progressive web app as we're getting close to the code camp and I need to get some more content out there explaining this. Now we'll be going over this in one of the sessions on Saturday, but I wanted to give a preview, maybe entice you to come to my session if you're going to be there. Anyway, so here we are. I'm looking at the code for the service workers. I thought I would walk through the actual code before we kind of step through part of it and explain some things. Well, first off, I'm using use strict so we can get the enforcement of better syntax. And I've got a recent blog post I made about what use strict is. If you're interested, I'll put a link to that in the description below. Now, the first thing that we do is call the import scripts method. And if you're not familiar with this, maybe you haven't done a web worker or haven't done a service worker before, this is how you reference external scripts to use inside your service worker. And I have found this to be extremely useful and also kind of a pain in the rear at the same time. And the problem is that the files don't necessarily get updated as frequently as you would like. And that's because the browser cache headers are honored, things like that. So there's been a lot of debate about the cache busting on this, but I just wanted to bring that up as a concern because just because you change your service worker to force it to reload does not mean these files will get updated. So you just need to be conscious of that. And if you're trying to debug problems where you do update these files, that you do have to unregister the service worker and then re-register it is the best way I've found. Unless you're going to do some sort of cache busting, which I'll go over some other time. But basically, like make the file name a hash or query string parameters, things like that. All those kind of cache busting kind of techniques. Anyway, so what I am using here is local forage, which is a little library that I found. It's not little, it's small. It's well documented, but you can't use local storage in a service worker because it's not asynchronous. So that's one of the reasons why I have migrated all my client-side data storage to IndexedDB. However, the IndexedDB API is rather complex, and honestly, personally, I don't really know how to work against it because I've always used something like a local forage. And the reason I use local forage is because it gives it an API that looks like local storage, but makes it promise-based, and that makes a huge difference. So that's what I do. I use local forage a lot of times to persist stuff in IndexedDB, and it makes it nice and simple. Next is Mustache. Again, I've got a article I recently posted on how to use Mustache, but it's been a staple of my client-side rendering for a long time, but in recent years I've been migrating a lot of stuff to Node server-side rendering as soon as the data is updated, and I use Mustache there as well. But as we'll see in the service worker, we can also use it to render things inside the service worker. You got to remember, a service worker is a proxy between the browser and the server, but you could actually use it to serve a lot of the purposes that a web server would do to actually render stuff on demand. And that's essentially what we're going to do if we're offline. And I'll show you what happens there as we go down through the code here. And the last external library I'm going to use is the sessions library. And this is the same library that I use in the client-side code to manage storing things in and out of local forage, or in and out of IndexedDB through local forage. So it's the same exact library, and I'm able to use it in both places because the library is designed so that it doesn't have any UI integrations or dependencies. It's really I think a repository or a service. I forget what that would really be called in a computer science philosophy kind of thing. But basically, it's the way to manage the session data, and local forage is the data abstraction layer. I think it's right. Anyway, it's the interface to the data layer. So anyway, all right, onward we go. So next, I declare some constant variables. I always declare a version number, and you'll see why here in a minute. It makes managing cache is easier. So I always give the name of my caches here, and I like to append a version number here. That way, if we want to upgrade the service worker version, as you'll see in a minute, I can clean it up very easily and delete legacy caches. Next is a list of URL assets, or files, if you will, that I want to have pre-cache, which means as soon as the service worker loads or gets installed, these will be added to this pre-cache cache, and they'll be available all the time. Now, the only thing I'm not doing here is pre-caching all of the sessions. Now, I did that intentionally so I could show you how to do this technique. For a site this small, meaning that there's 65 pages, and these pages are relatively small. There's only one image, I think, for the entire site too, which is the logo. This is a very simple site, and honestly, like I said, I'm going to replace the Font Awesome reference with a magnifying glass image so we can get that out. So these files will go away. I'll minimize or find just the CSS I'm using, so that will go away. So in the end, this is going to be super small. So I could technically pre-render all of the individual session files or URLs and make those available. And I could also pre-render just the content and use the technique that I'm going to show you here a little bit later. And that's because this is really a small site. I mean, 65 pages may sound like a lot. It's relative, but the actual amount of data is really small. And there's some cool things that I could probably do to make that just cache the entire thing locally. But I'm going to be rendering things a little dynamically if we're offline, which is kind of cool. So, anywho, alrighty. Now, let's go through some event handlers. This gets into the lifecycle stuff. Lifecycle, I've got like a couple hours of lifecycle content in the course. So this is obviously going to be a real quick one, but there's a couple of steps that a service worker goes through when you register. The first is the install event triggers, and that's when it is first registered. And normally what you do is you set up your pre-cache. That's like the primary thing you do inside the install event handler. This is where you cache those assets up front that you know are going to be needed all the time. And the other thing I'm doing is I'm calling skip waiting. This makes the service worker immediately available. And again, this gets into the lifecycle concepts. I'll talk about this some in the session on Saturday. But like I said, I've got about 2 hours worth of content in the course alone just on the service worker lifecycle. So I am calling caches. I'm opening a cache, the pre-cache here, and what I'm doing is I'm adding all of those URLs that were in that array up there. This will just take care of fetching those and stuffing the responses into cache so that they're going to be available. Now the next event that triggers is activate. This is actually when the service worker becomes the active service worker. And that's because the service worker, when you register, it doesn't immediately take over for a lot of different reasons. Now the skip waiting will make it immediately active, but there is a kind of a process to get there, and that process honestly is not going to be that long if you do the skip waiting. But anyway, so this is a separate event, and typically the thing that you do here is you kind of go through and clean up caches if, and this is a standard routine to kind of loop through all the caches, and here I'm checking to see if the version number matches with the current one. If it doesn't, then we delete the cache and get rid of it. That way we don't like take up a lot of excess space if we don't need it, that kind of stuff. Now there are some other ways that need to get that you would want to do to kind of manage your cache and validation. I kept it simple in this particular application. Now in the workshop I'll go over a lot more about the cache and validation. We'll try to go over some of that in the session on Saturday, but I don't have enough time to really cover that in earnest. I'll just kind of talk about it. I did write an article on Perf Planet this past December, and I'll try to put a link to that in the description as well. It's not in here, so it's not that big a deal, but anyway, this activate event will only get called once in the life cycle of the service worker, and the same goes for the install event. Those are only going to get called once. Once the service worker is registered and become active, these events will not trigger again until you replace the service worker, and then it'll go through that service worker's install an activate event. All right, so here's the workhorse of any service worker is the fetch event handler. Now you could also have push event handlers and background sync. That's very outside the scope of this session or this application. But basically, anytime a request is made to the network, this fetch event handler will fire up and intercept it. Don't worry, it's not going to really slow down your response time. In fact, it will increase, especially if you've got things cached locally, which is what you really want. Now you're going to respond with, this promise kind of thing that's going on. And down here are the returns. Now, I'm not going to go into the details of that, but basically the event's going to have the request object that defines how you're requesting. It's going to have the URL, the headers, all that kind of stuff associated with it. First thing you're going to do is you're going to check all the caches to see if you already have a response match. The first response for this request that is found will be returned. And here you want to check if you actually got a response. If so, then just return it. You're good to go. Nothing else needs to happen. Now I'm using a pattern. It's basically called cache falling back to the network with an offline fallback. Okay, and I know that's a long name, but basically that's what's going on. So the next thing we're going to do is we're actually going to make the network call. And this is where we're going to actually make a fetch here, and we're going to pass in the request. Like again, you've got a request object, and you can just pass it on to again. We should get a response from the network as long as it's okay, which means it's status 200. Just be careful here if you're doing other things. Maybe you get a status 204 or different kind of responses, especially to in response to posts and puts and deletes and things like that. You just need to be careful about how you handle these responses. Here I know it's only gets, and I'm only looking for OKs, so I am good there. Next, I don't know why, but at least locally, I get it. All the Chrome extension requests go through here too, and that causes problems. And so what I do is I don't want to cache those responses. So I just by default try to not cache those responses. You know what I probably should do is just do HTTP and HTTPS or whatever in here. That's probably going to be a cleaner way to do it because there's probably other things I got to do. Now that I've got the response, I do want to cache that response. Now you can't cache the response and return it to the client. So what we do is we clone it, and this creates a deep copy of the response, and I cache the copy. So what we do is we open up the dynamic cache, and then we get a reference to that cache, and we put the request and the response copy into that cache. And you have to put both because it has to be matched up, because when you check to see if there is a response in the cache, it's going to look for the request as the key, and it has to match up. Now if this request excuse me, is to the same URL that has different headers, that is a different request because that can trigger a totally different response. For example, if you used a different content type, maybe form body versus JSON, which you probably wouldn't want to cache a post, but that would be the case here as well. They would potentially create a different response. So you could have potentially two different responses cached to the same URL, but because a header is different, then that could trigger a totally different response. So now that we've cached it, we're going to return the actual response back up to the client, and all things are good. But what happens if you're offline? And this is going to happen a lot on phones because cellular connections are intermittent. And this is one of the things that we can really make our application shine. Well, if the network is down, then you should fall into your promise catch handler here. Now here I'm checking just to make sure that it failed to fetch, because we could have some sort of other strange exception thrown. So I just did this as a little gate. And I'm also checking to see if the request was for a session. And this is just because this is a simple application, I can do it this way. So basically, actually I need to do this. I need to add that to it. Sorry guys. But basically, if there is a session included in there, then what we're going to do is we're going to go through a routine to render it on the client. And this is kind of an advanced technique. So what we're doing is effectively doing what I would normally do on the server side. I just basically, honestly, I took that logic and I put it in the service worker. And I can do this because I have all of the data locally. And if we go back up, I don't know if you saw this, but I cached the templates to actually render the individual data. So I've got the template for uh, like the list, and then I've got the session detail page template here as well. Now that's not going to be the full page. What it is just the template to render the main content in the page, and that is what we do. So this is going to get a little detailed here. I probably should have refactored to make it a little cleaner, but it works, and I'm fine with that. So I've got a method to just parse out the slug, which is going to be the last part of the URL, and it's just a simple split thing. I won't go into that. But I've got a method where we go get the main app shell, which should have also been pre-cached up here somewhere. Trust me, it's there. Oh, here it is. Yeah. So these are the 3 HTML files. Okay, I should have highlighted that, but that's okay. All right. And as soon as we get that markup back, then we go get the session template. I know I could have probably done like a promise all kind of thing here. It's not my strong suit when I get into that part of promises, so this works. Okay, so when the session detail template is found, then we're going to get into, just like we did in the build script. If you watch that video, I just drop the session template into the app shell and make the entire app shell a single page that we're going to merge stuff in. Again, the reason why I do that is so I can set the unique title, descriptions, meta tags in this particular case, but there may be other fields in your header that need to also get set to be correct. Next, I'm going to call a method where we get the session by the slug, and that's going to call into our session library to extract, and then we're going to filter the array. I'm not going to go into that just to save time, but if we do get the actual session object back, and I honestly should be checking to make sure that we did, that it's actually exist. I just assume it will. Anyway, and then call mustache.render, pass in the template here and the actual session data, which is in JSON, and that will give us the entire page back. And here we're going to build a custom response. So what we do is the response is the actual markup, and then here are all of the options, and this is going to include the headers. And we really don't need to get too fancy with this, just need to set the content type to text HTML, and that should be good enough for this. And what we're going to do is just follow our process again. We're going to clone the response that we just built. We're going to add it to our dynamic cache, and just like we did above, and then we're going to return the new response to the client, and that will make it all work the way we need to. So that's a quick run through of the Philly.net progressive web app and the service worker, and the little advanced technique there to handle the offline mode. And what we want to do is actually go look at this. And if we do that, we go into, and let's see, I'm going to make it an offline. And if I go into the details here, we actually step into it. I just wanted to show you that this is where we step in. And if I hit F8 to make it render, you can see that the detail page actually renders and all is good to go. So there you go. That's the magic of the service worker and handling offline mode.